So namaste to all. It is very nice to see from various backgrounds, various levels, all have gathered in one particular place, and really great standing here. And this session what we have, we will learn something new and something unique also. Okay. So my name is Rohith. I am currently working as a principal of New Hardwick Indian School. I have done my basic degree in science, that is basic science, physics, electronics, and then mathematics. Then I took physics as major in my MSc master degree in Bangalore Central University, which is there in Ambedkar Vedi, right there. And then now there I took condensed matter physics as my major subject in the second year. And now I am currently doing my research in nanophysics, nanoparticles, which is applied physics in Amity University, Madhya Pradesh. Okay. So this is my educational background, and I started my career as a lecturer in 2020 during lockdown in the same school which I studied. Okay. So I started with teaching ISC students class 11 and 12. ICSE students class 9 and 10 physics, and then I moved to Byju's, started coaching the NEET students there, and then later I came to the school, New Hardwick Indian School, where I am currently working. So this is my short introduction. Now, how many of you are from science background who are preparing for UPSC? Okay, commerce background? Arts background? Okay, and all others are school going still. Okay, fine. So, shall we start with the concept? Okay, so nanotechnology. Can anyone tell what nano means?
10 power minus 9.
What is this 10 power minus 9? 10 power minus 9, very good. What is this 10 power minus 9? It is the value of nanoparticles. Okay. So any object or any particles, if it is in this size, in terms of 10 power minus 9, 0 to 100, it should be in this range only. 0 to 100 nanometers. Nano refers to 10 power minus 9. Okay. If it is in that scale, then we call it as nanoparticles or nanomaterials. Then what is technology?
Innovations.
Innovations. Okay. What is an innovation?
Creating new things.
Creating new thing. Why we have to create new things?
For our own use.
Very good. For using it, applying it. So what exactly technology word means? You can give a try, no issues. You can give a try. It's very good. It's innovation, creating new things. What exactly what exactly technology means? It is something related to science, right?
Yes.
We could have called it as nanoscience. Why technology?
It's a systematic methodology.
That is science again.
Scientific knowledge.
Science again. Why technology?
Manipulating the things which is already present.
Manipulating the things which is already present. Yes, that is again innovation. Creating something new. Something, if I am manipulating any device or something, it is creating only, right? Okay, so technology means we have science. Using science, we will create new things, which is told by your friend. Using systematic way, using science, which we already know the facts, we create new things which we can use it in everyday basis. For example, how many of you are using phones here? Everyone, right? In olden days, what we used to do, we used to take a stick and then do it like this, right? Later, hardly you had to press. Then later came touch screen, which is very sensitive, capacitive screens, right? where only your tip of the finger has to touch and it will work. Then 5 fingers would work there. Now the touch screen is completely full screen you will get, right? And if you keep it on in the pocket, if there is any key, it would get scratched earlier. Now that problem also solved. Ceramic shield, Gorilla Glass. What are these things? Yes, we are giving the solution for the problem. Yes or no? That is technology. Using what? Science. So nanoscience and technology goes hand in hand. We think, we study, we apply. That application is technology. Any technology which is happening in nanoscale is known as nanotechnology, right? Now we will start with this nanotechnology. We got to know what is nanotechnology and all those things. Where it all began. I am using this duster. It is made up of wood, right? Do we have nanoparticles in this? How many of you can say, how many of you will say no? What is this made up of? Wood. Again, wood is again made up of atoms. There is cloth which is made up of fiber. Fiber is again made up of atoms. Everything around you is made up of atom, but we do not call everything here is a nanomaterial, nanoparticle, even though everything is made up of atoms. So when atoms comes together, they behave in a peculiar way. For example, here lots of wood particles have come together. It is forming a duster. Duster is not a nanoparticle now. It is a macro particle. What is macro? Which we can see, which we can feel. Yes or no? Macro means large. Nano means very small. When we go down deep, when we break down, if we take this duster and break down, okay, at one point we reach small size, that is 10 power minus 9. What 10 power minus 9 actually means? Very small. It is very small, where 0.0000000. How many zeros are over now? 1, 2, 3, 4, 5, 6, 7, 8, 9. Term will be your 1. Just imagine that much meters is a nanometer. That means your hair, you should divide it around 5,000 times. 5,000, just imagine, very small it is. So at that particular the size, any particle, any atom behaves strangely. If I throw this duster outside, I can predict where it goes, but I cannot predict what nanoparticle it is, what an atom behaves. That is our quantum physics, our new realm of physics. Okay, quantum means very small. Any particles around at that particular level behaves strangely. So why we are using nanotechnology? Because of this strangeness. Normal physics does not apply. New things can happen now. How can we make a mobile screen scratch resistant? That is nanotechnology. Because now atoms are behaving different way. Even if you take a knife, if you do scratch it, it will not get scratched because of this peculiar character. Okay, we'll go deeper into that now. Now, there was a famous scientist called Richard Feynman. He gave a lecture about this nanoparticles. He said there is plenty of room down there. So He said there is plenty of room down there in the year 1959. What does it mean? Plenty of room means he's not speaking about space, empty space. He's speaking about there is plenty of innovations, plenty of permutation, combination that can happen in the world down there means at that particular scale. So he gave the idea to the general public and scientists thought about it, and then please you can see. So he gave the idea, then people started thinking about that, they started doing the research. So he was the person, Richard Feynman, who was the first person to speak about this, and he is regarded as the father of nanotechnology, nanophysics. Okay, so in the year 1959 he gave. Then he did not use any word called nanotechnology there. He was using small particles, quantum particles, like that. Nanotechnology, the word first used by a Japanese scientist. Okay, he is called as Taniguchi. Okay, he experimented on various nanomaterials. Okay, ions and electron beam, so on and so forth. Okay, he was the first person to give the definition. He was the first person to tell. He's a Japanese scientist. Okay, in the year 1974. Then now we are standing. We only know 3 to 5% of nanophysics. That's all. And n number of possibilities we have. What possibilities are there? What are these nanoparticles exactly? Still we don't know, right? We don't know still. I told 10 power minus 9 meters, these are the particles, so on and so forth. These give so many different kinds of properties. What are these nanoparticles exactly? That we will see. How many of you have seen church? You have seen church? If you go to a foreign place, okay, there used to be glasses. In olden days, we did not have red color. Red is very scarce. Naturally, will not get anywhere. Only one insect is there. Okay, from that we can extract carmine. You might have known that carmine is red color. Okay, carmine red. Only that is the naturally occurring red pigment that we have in the nature. All other red pigment which we have, it will degrade and it will become different color. But in olden days, in very past, they created red color glass unknowingly. What they did is they took gold, they grinded it very smaller and smaller and smaller. They mixed with glass. It was giving reddish hue. Similarly, green, yellow. So Lycurgus cup, that is a famous cup in Greek. Okay, so that also was the colors of that also was based on these nanoparticles. So when we make the particle very smaller and smaller, its physical state changes. Gold, we get the golden color which is here. When it is broken down, it may give green, it may give red, different colors as well. Okay, and carbon, which is the strongest material. Diamond, yes. I'll say no, this is not strongest material which is available. Strongest material is not this. We have graphene. Graphene is the strongest material that is accepted all over. What is this graphene? That is also carbon. What is diamond? Diamond is also carbon. Both are carbon. Carbon-carbon covalent bonds. You know difference between graphene and diamond? What is the difference? Graphene is little bigger compared to diamond is little bigger when compared to graphene. If we observe, we will take atom, carbon atom like this. I'll arrange like this. How many of you have seen honeycomb? Something like this. Something like this. These are all individual atoms. Graphene is just this. One flat individual atom arranged like this. But your diamond is not like this. There are so many other layers also, which is built up. See, if I cut and make it in a thin sheet, it is stronger than that. That is the power of nanoparticles. Its physical property changed now? Yes or no? Isn't that useful? Now, how can you make this phone very strong? Graphene. We use nanoparticles there. That is not the only application. There are so many n number of applications that we have in nanoparticles. Okay. How to synthesize this? How to make nanoparticle? How to create a nanoparticle? There are two approaches. One is top down. Another one is bottom up. One is top down method. Another one is bottom up method. In two ways we can synthesize. I'm not going deeper into the subjects actually. Okay. So that it will be understood by everyone. Okay. So what is this top down and bottom up? You know, in olden days, if you go to your native or in a countryside, what they'll do, if they have ragi, if they have some rice, if they want to make it into flour, what they were doing? They used to grind it using stones, two stones. What exactly was happening there? Size reduction. That is top down approach. We have duster, we will break it down to smaller pieces, and we will stop when we reach this size. Okay. Then what is bottom up then?
From 9 you should add.
Very good. So we will take atoms. We take single atoms, combine it together, one more atom, then we will get nano size. That is bottom up approach. Now the question is, can we see atom? Can we hold atom? One interesting thing I'll tell you. I'm holding this particular pen marker, right? Actually, my hand is not touching it at all. No, my skin is not in contact with this. You are all sitting on the chair, right? Do you think your clothes or the chair is in contact with you? No. You are, flying over it. Why? Because no two atoms can come closer together. Never happens. Then you can feel, sir, I can feel, I can touch, right? That is the exchange of temperature, that's all. This particular board is colder than me. When I touch, my heat gets transferred to it. It's now, whatever the heat I have lost, I will sense. That is touch. I'm not touching it. Right? So, how can I hold this atom then? How can I bring this atom together? Pressure, okay. Okay, using pressure, how can we hold this atom together? How can we have this atom combined together?
Applying heat or something.
See, applying heat, that can be done. When we apply external energy, for example, this board, to see it is static, it is not moving. But when we see it in an atomic level, the atoms will be doing like this. Still water, correct? When you start giving the heat, what happens to the molecules? It goes here and there. Kinetic energy is directly proportional to the temperature. So if you give external energy, again it will move here and there. More, it will move here and there. You cannot hold it. If you can hold it with the light, but light again makes it vibrate, because light is it is a kind of heat only. The electrons will absorb the light. It may emit the radiations. It is not possible, right? And first of all, do we have any microscope to see atom? What is that microscope? Yes, STM, SEM, TEM. Yes, A. Okay. So, what are these? Did we have in 1974? Did we have in 1959? No. So, we scientists were thinking all about this theoretically at that time. The first microscope to be invented was this transmission microscope. Okay, and then now we have SEM and TEM and all. Okay, which is an electron microscope. In using this, we can see individual atom. We can hold it. We can do the things using optics only, light. We have that technology. What is technology again? We are using science to modify the science at atomic level. So, using these, a person can combine the atoms together and build a nano tube, a graphene, anything. Okay, these are the two approaches that we have. Okay. Why a particle should behave differently? I told that at that particular size, a particle behaves differently. Why? Why it should behave like that?
You have altered.
I have altered.
Then it will behavior changes.
No, see, for example, if I take water in a beaker, it is completely filled. I take one drop of it, I will drop it on the floor. Any difference in this water and this water? This is also made up of H2O, this is also made up of H2O only. Hydrogen and oxygen, right? Then what's the difference now? If I break the duster, this is made up of wood, it contains carbon, hydrogen and oxygen. If I break it out, again what molecule we will get? Carbon, hydrogen and oxygen only, right? Then what makes it peculiar? We are not talking about electrons, we are not talking about protons or quarks to go deeper into quantum things, right? What is it then? What it might be? Yeah. No, composition doesn't change. Water is water, H2O, two hydrogen and one oxygen.
Maybe with other
No.
particle it will change.
You are close, but it is not correct, sir.
Because if I put it on hand, it will differently act. If I put on fire, it will differently act.
See, one example I'll give you. Go home. You take rock salt and block sugar, powdered salt and powdered sugar. Okay? If you try to dissolve this in water and try to dissolve this in water, which will dissolve faster? I'll take this also 50 grams, this also 50 grams. Any changes? No. I'm trying to dissolve it. Timing should be same. but which is dissolving faster? Powder. The same thing applies to sugar also. Glucose, it is nothing but your powdered sugar, correct? What is glucose? That is what it is, right? Now, when you put it in the mouth, it will dissolve quickly. When you put sugar, will it dissolve quickly? No. What is happening there? What might be the reason?
Surface area.
Very good. Surface area. Surface area to volume ratio. Surface area to volume ratio. So when you reduce the volume, the surface area increases. Just think, we have a huge ball. The atoms which are outside only can interact with the environment, right? What about the atoms which are inside? Never. But when you break it down, each and every atom can interact with others. That is the speciality here. So that is the reason nanoparticles and nanophysics is in boom. Why? This is the main key thing. That is the main key thing. Okay? So what will happen? If light enters, it will absorb. If light wants to be emitted, it will give. If something needs to happen, if electricity has to pass, it will pass. If electricity does not needs to be passed, it will not pass. We can tune it according to our things. Just think, I have metal, a big metal. This is also metal, correct? I'll take a wire, 2 wires I will take. One I will put in this hole, one I'll put in this hole. Okay, I will give it to here, to the bench which is made up of metal. What will happen? Yes, spark will come, current flows, correct? What is that current? Electrons, yes or no? Electrons will flow from one place to another place. Freely it will flow. Now, if I break down the bench into 2, now electron will go here, only here and here. If I again break down, it will go from here on here, that's all. At nano scale, I can create a well, potential well. If any energy is given, okay, that energy I can tune it up, how much energy it has to emit, I can tune it. For example, there is this LEDs, fluorescent lamps, this and all. How exactly the light is coming outside? Emission of emission of photons, right? Emission of, again, photons are nothing but energy. Light is a form of energy, 10 standard, right? So this is one orbit where electron will be there. So if this is the atom, so many orbits will be there, right? Here electron, here electrons, right? Correct? I am taking 2. One electron is here. Only one electron I am considering. Just to understand what is happening there. I can give the energy in the form of heat. I can give it in the form of pressure, anything, any energy in the form of anything. Okay, I will take in the form of heat. If it is given in the form of heat, this electron absorbs that energy. When electron gains the energy, it will jump to the next orbit. When we have money, what we will do? We will jump here and there, we will eat Golgappa, we will eat this, that, this, hey friends, we will call friends, we will go here and there, right? The same thing is happening here also. What this electron is doing? It is jumping to next level. If we have money, will it be forever? Will it be there forever? No. Energy also has to be lost by electron, because its own house is this, correct? It has to come back. While coming back, what it has to lose? Energy. It has gained energy, it has to lose energy. That energy which is lost, it will be in the form of light. This is H, this is nu, that is H nu is nothing but your energy. Okay, that you will learn, we will not go deeper into that. Fine. So now what is happening? This electron is getting the energy. This is exciting. While coming back, what it is giving? Light. What if there is one more orbit? I give more energy. This electron will jump here and comes back. Yes or no? Every time, if we see here H nu is nothing but your frequency. Okay. Any colors will have definite frequency, and it has its own wavelength. Red has more wavelength. Violet has least wavelength. You have heard now in 10th standard, right? More wavelength, high speed. Red light will bend slowly. Correct. It will bend less. Violet will bend more. Correct. So here also, it depends on frequency. From here to here, if it is going, it may give you some red color. If it is going from here to here, it may give you one blue color. If it is jumping here, it may give you a green color. Right? So what I am doing here? I am tuning the material. Okay? By making it smaller and smaller, I can give only space. If I don't have this energy level at all, can it go? No, it cannot go. If I don't give this energy level, can it go? No. That much energy I will give. You might have heard, this particular television needs this much energy, or else it will not work. Right? And then you might heard about LCDs, LEDs, all those things. Correct? Everything works on the same principle. But what about QLED, which you are using now, that is quantum LEDs, which uses nanoparticles. We call it as nano dots. Quantum LEDs. Specific colors you can see there. If you want black, nothing will be there. No light will come out. If you want red, only red wavelength will be coming out. But what about olden days? Mixed colors, RGB? Yes or no? It is not like that now. That is the reason Samsung, it is in high, their technology in nanoparticles is very good in terms of LEDs. They are using QLEDs now. If you go to some Reliance Smart, you can see that QLEDs. It is not like a new alien thing. It is already there. Right? Okay. So, very good. So, the main thing which is making the nanoparticles behave in a different way is surface area to volume ratio. Okay. More smaller it is, more surface area it gets. More it can react with the environment. Now, I told you about graphene, correct? What is two-dimensional? What is a dimension?
Visualizing any object.
Visualizing any object. No.
Length and breadth.
What is this length and what is this breadth?
Height and width. When we see something.
Yes?
Which angle we see?
Angle, no, that is another thing. What is dimension?
On flat surface.
Yeah.
Length and breadth.
Okay, just tell me one object which is two-dimensional.
Nanoparticle. Only one layer of atom.
No. Any object which is two-dimensional.
Rectangle.
First, I will tell you what is dimension, because most of you are like, oh, what she is telling. Okay, first I will tell you what is dimension. Okay. Any object, if it can go left, right, only in a straight line, that is one dimension. Correct? Either it can be x-axis or y-axis. Correct? That is one dimension. Either it can go only like this or only like this. If it can go like this, that is two dimension, only on a flat surface. If I take this board and keep it like this and right here, will it be applied on the board? No, because the flat surface is here now. Correct? That is called as plane, two dimensional, flat surface. What is 3D? An object can go here, come towards you also, go behind the board also. That is 3-dimensional. Okay. Now tell me one object which is 2-dimensional.
Screen, sir. TV screen.
Screen. See, isn't this board appears to be 2-dimensional?
Yes, students.
But if I go behind, if I see from here, there is some thickness. Right, what I will do in my imagination, I will reduce it, the thickness, very thin sheet I will make.
One plane.
Okay, one very thin sheet I will make. Again, I will zoom now. What I can see, maximum I can concise it to be an atomic layer. Yes or no? That's all. Can I reduce further?
No.
No. If I reduce further, what will happen? This board will disappear. Correct? Now also we have thickness here. Some thickness will be there. Atom has some thickness. Right? That means 1-dimensional, 2-dimension is ideology. We live in 3-dimensional world where we can only imagine 1D and 2D. There is no 2-dimension, there is no 1-dimension. It is there. It is there. But we can only imagine. We can only represent it. But do we have it in reality? No. We have 3D. So what we consider the smallest thickness layer is 2D now. Okay. Now I will take this made up of carbon. Okay. I'll just coat one layer of it on mobile screen. This particular atoms hold very strong together. Even if I cut, if I break it, it will not break. It will not go away. The atom and the atom will be attracting so strong. It will not go away. Okay. So it is very lightweight also. They only do not use this in mobile screens or something like that. They use it in spacecrafts, aeroplanes, so many other places. Now what I'll do, I'll take thin sheet of graphene, I will roll it. It will become a tube, correct? These are nanotubes.
How big is the tube?
So this tube can be used. For example, I will tell you, I will take one paint. Okay. Two things I will do. One here I will put black. Here also I will put black only. I'll come to this later. I will take Rangila paint, Fevicryl paints, all those things. I'll just paint it here. What black color does? Absorbs light. When I put the light, nothing will come out. That is the reason it appears to be black. What if I give more intensity? It will appear to be something grayish. Correct? It starts reflecting the light. Yes or no? But here, if I do the same thing with some nanoparticles specifically designed and paint it, no light will come out. It will be pitch black, which is very costly now, but it is there. That is nanoparticle, where each paint, when we observe in the microscope, will be appearing like this, like so many tubes. When light falls, it gets absorbed, because higher surface area to volume ratio. That is the reason. So we do have this. Okay. So that is the power of nanotechnology. Only these things, only in engineering and electronics like this. How many of you have seen the ads and then this one where foldable phones are there, flexible screens are there? How these are made? Again, nanotechnology there, nano membranes. Okay, so we take polymer. Polymer is again your plastic. Okay, we take polymer. We make the polymer with the help of nanoparticles. That is very flexible. The screen works. Okay, so that is and all these things which we were discussing, where we were using semiconductors, that this and all. So what now we will come to one proper semiconductor material. Semiconductor. What is a semiconductor? Can anyone tell? Very good. Semiconductor is a device or a material whose conductivity lies between a conductor and insulator. We know metals. If I give the electricity, electron will flow here and there very fastly. If I give it to a plastic, can electron flow? No. It needs more energy to be given. But for semiconductor, if I give less energy, it will not conduct. It will behave like insulator. If I give more energy, cross the limit, not more than insulator until then. Okay, just energy which can be more than this one, threshold one. It starts conducting. That is semiconductor. Using that only we have diodes, transistors, so on and so forth. Diode is a basic device, basic semiconductor device. What is LED? Light emitting diode. Correct. What is QLED now? Quantum light emitting diode. Okay, did we learn this?
Yes.
Did we learn?
Yes.
Yes, we learned this, right? Where we broke down the material, we kept the atom in a well where electron was going only here and here. We tuned it to give specific colors. Correct? That is QLEDs. So these transistors and diodes are used more in semiconductors. In olden days, computers were kept in big rooms. Okay, this was the size of transistors initially, very big one, where here P-type semiconductor may be doped, here N-type semiconductor may be doped, here P-type again, or vice versa, N, P, N, like this. Okay, we wanted so many transistors like this piled upon like this. Now, one computer which was giving only, what is that, zeros and ones or something like that, basic calculation, addition, subtraction, only this basic calculation was doing. Now we can play video here on my phone. Isn't my phone a computer? It is a computer, correct? We can make n number of things. See, now we have a phone here where it is capturing the video, it is giving to the server, and the server is uploading it to the, it is uploading to the YouTube application where other people also can see. Correct? All these things are happening in real time. And thousands of transistors needs to be placed here. Do we have that much space in the phone? No. How is it possible then? In the year 2000, in one chip IC, okay, 250 transistors, one for performing basic operation, 250 transistors had to be used. Okay, it can be fit. Now millions and trillions of transistors we can give. Millions and trillions, just imagine. In a small IC which is this much big. And your microprocessor, microcontroller also has trillions, billions of transistors. And it was around 200 nanometers along before 10 years before or 15 years before. Now it is around 3 to 5 nanometers only, one transistor. Just think, if we reduce the size, more transistor can be accommodated. More transistor, more operations you can do. Operation means no, not surgical one. Performances, it can be arithmetic, logic, anything. Okay, right? And you have seen hard disks, I guess, right? Hard disk, pen drive. There was any pen drive in the year 2000? No. We had hard disk. Now we have SSD. Correct. Now we have come to this much big one, pen drive, which can accommodate 2 TB, 5 TB also, terabytes. But only small, it's much big. How the data is stored there? How the data is stored? Any information, how it is in the form of bits. If I tell 1, means it will be 0, 0, 0, 1. If I tell 0, 0, 0, 0, 0. If I tell 2, 0, 0, 1, 0. If I tell 3, 0, 0, 1, 1. Something like this. Correct? It goes on like this. Now I have to store some data. Okay. So this will be combination like this only, which how we have given for 1, 2, 3. The same way we have to give for alphabets also. It has to be stored in somewhere. Correct? If I will take one photograph, that photo, it has to first convert it into zeros and ones, and then it has to be stored. Okay, where it will store? It will store in the material. How it will store in the material? Will it tell 0 here, 1 here? No. What is on and off? So, for example, if this is the atom, all materials are made up of atoms, right? Okay. Now, I will tell, hey atom, please be on. Yes, exactly. I have to give energy. If I give energy, what it has? Charge. If it has charge, then 1. That is our interpretation. If we don't give charge, that is 0. Now I will give 0 here, 1 here, 1 here. What it became? 3. Like that I have to make the material do it. Okay.
How can it stay, power can stay there?
Electrons. I am confining it again. I am making it.
Give energy. It will lose. If it will lose, it will come to different.
Yeah, that is the reason you can delete it. How you can delete? By removing it. You can make it.
No, you can make that to stay there.
Yeah, we can make it to stay there. Again, if it is damaged or rubbed, again it will go off. The charge may get altered. That is the glitches. Old CDs, if you play it now, it will not work properly. That's the reason. Now, that depends on electrons, whether it is charged, not charged. Correct? Now we have something called electron is not just revolving around the nucleus. How our planet Earth is revolving around the sun like this. Also it is rotating. Similar way, it is not same, it is similar way, even electron is spinning. It can have 2 spins. Okay, positives or negative. Based on that also I can do now. If I think if electron is spinning left, 1. If electron is spinning right, 0. I can assign. That is your quantum computing, spintronics, not electronics now. We spoke about electronics. Now it is spintronics. Again, where we are doing it? In nanoscale. That is nanotechnology. Isn't that interesting? huge amount of calculation can be done here. Very small IC can do multiple job. That is your quantum computing is spintronics.
Like spin, we cannot determine also.
Yes, that can be, it is not like that, it can be determined whether it is, it depends now. So if it is spinning left, it behaves in a different way. If it is spinning right, it behaves in a different way. How we can tell it is negative half, positive half?
By loss of electrons.
Its behavior. That is what we are understanding. How do we know? See, even Pauli tells that, so if you are, graduate of science, Pauli tells that, sorry, not Pauli, what's that? Heisenberg. So we cannot determine the position of the electron. If we want to study the position of the electron and how fast it is moving, we cannot do it together. What we can do, where exactly at that particular point or what speed it is revolving. If I want to study both, it is not possible because it behaves in a different way at that particular place. That is, Heisenberg uncertainty principle, right? It's the same way there. But we are making it use, now we are using electronics, even though there is this anomaly. So that is the thing, okay? So that is our spintronics now. In the future, your kids will be learning about spintronics, not electronics. Only in electronics and spintronics or some other engineering we are doing this? No. It can be used in medical field also. Medical field.
You want to take a break for 5 minutes?
You want break?
10 minutes?
12:15 it will be, sir.
Okay.
12:15.
Okay. Till 12:15 it is break? Okay. So have a break for 15 minutes. Okay. Thank you.